A very good morning to all. On behalf of the Indian Biogas Association, it is a matter of great honor and pleasure that I'm extending a very warm welcome to all of you. Now, we all are sanguine of the fact that anaerobic digestion of organic waste produces biogas, whose main components are methane and carbon dioxide. Now, to make bioenergy, the methane is separated from the carbon dioxide and other critical components as well, and then liquefied. Now, this liquefaction process, it increases the energy density almost 600 times and makes the biofuel ideal for heavy duty and maritime transport. Now, in today's webinar on navigating the landscape of biogas upgradation, which is supported by MVS, our eminent speakers would also be delighted to touch upon the perspective pertaining to bioenergy, which is not only a carbon neutral fuel, but comes with numerous advantages as a renewable replacement for LNG by fostering reduced carbon dioxide and nitrous oxide emissions, less particulate matter emissions, lower engine sound, and so on. Also, we feel privileged to gear up during this propitious period of Amrit Kal, paving a way towards building Atmanirbhar Bharat and Viksit Bharat. A paramount contributor towards attaining this would be adoption of agro-PV systems, adoption of which shall not only increase the land use efficiency, but also have a plethora of other positive synergistic effects for the agri sector, like climate change protection of sensitive crops, improved water efficiency to address the plight of small farmers, while on the other hand, address pressing issues like heavy rainfall and so many other issues as well, like solar irradiation, hail, which could be a potential threat to the crop yield. Now, this would very well be addressed by simultaneously bringing the countrymen a sustainable solution to their energy requirement while providing precious biomass. So without further ado, I would like to request Shri Jagdale sir to kindly enlighten us with his thoughts further. But before that, it is my absolute privilege to introduce him to all of you. Now, Shri Jagdale is presently working as Joint Secretary at the Ministry of Renewable Energy, New and Renewable Energy. His experience spans more than 23 years. He has served as Director and Chief Executive Officer at Panama Renewable Energy Group for over 8 years. He also spent over 15 years working with Enercon India Limited and Crompton Greaves Limited. He earned his Bachelor's of Engineering from Walchand College of Engineering, Sangli, and MBA from MGV Panchvati College, Nashik. Over to you, sir.
Good morning, all of you. Welcome to this webinar. First of all, my regards to Dr. Shukla and other panel members, Dr. Kedia and others. It's a privilege to be a part of this web series as you have been doing for the past several years. Always pleasure to be amongst the biogas fraternity, the biogas family, which I believe has been doing a lot of work on ground. That there has been a lot of improvements, there has been a lot of policy interventions. And as far as Indian Biogas Association work is concerned, we all know that the intervention that you have been doing in this particular biogas field over the years under the able and very, very knowledgeable guidance of Dr. Shukla has been tremendous. We have seen lots and lots of interventions that have come and that have put across to various ministries in the government of India have now been realized over the last years, and that is because of a perseverant follow-up by empowering the lawmakers, the policymakers with the kind of subset of knowledge that you present. So first of all, my kudos, cheers to all of you for bringing that overall approach in the policy making. Today's topic obviously important from an aspect where the country is aiming and is galloping in terms of its policies, in terms of projects on ground and towards a complete climate change leadership. India, as you all know, has been taking that strides year on year. We have been achieving the kind of targets that have been set in renewable energy and into clean energy and absolutely on ground in terms of meeting the NDC targets, the nationally determined contributions, well ahead of time. So for the further years down the line, I think biogas, bio-CNG aspect is going to be critical. Therefore, bioenergy as a whole overall approach towards the bioeconomy, as we can say, with the help of Ministry of Petrol, Natural MOPNG, the natural petrol and natural gas, supported by other ministries, and my ministry, Ministry of New and Renewable Energy, has, as you all are aware, the bioenergy programs where we are supporting through central finance assistance and other support in terms of enhancing the on-ground ease of doing business to all developers. Today's topic, and I was talking with Dr. Gaurav Kedia over the several many months about how this entire approach can be now hybridized, can be unionized in terms of making efforts in reducing cost, in enhancing a yield, and also looking at a very robust supply chain or a robust ecosystem. Solar has evolved, as you all are aware. The people joining this webinar are totally aware that the distributed solar as well as the large solar and other RE technologies have been now very well established. So I would really like to just put a few points for this in today's context as we are speaking. The development model of the bioenergy, the CBG field has come very, very forward in terms of the technological improvements in the biomethanation process, technology improvements in the yield that the methane yield is getting converted into the natural gas. And also one more aspect I should say is about the ability to use a multiple feedstock has really, really improved over the last 3 to 4 years. A lot of people have put a lot of knowledge and resources behind this. And today we can very well say that the technology has been considerably improved with what was there probably in 2020, as I can say. Now it is so what can we do more in terms of that? So there are several ways of imbibing other technologies while you're doing a bio CNG project. The cost of solar today, as you can see, has decreased to a considerable extent thanks to the improvement in technology and thanks to the overall approach of the various governments, including our government, in trying to bring volume and scale and productivity enhancement, which enables now for everybody to put up solar power plants. And I just want to inform this audience that during the last month on 29th of Feb, the cabinet, the government of India approved one of the largest distributed energy program, the rooftop solar program called PM Surya Ghar Muft Bijli Yojana. And this is one of the schemes that have been launched by the ministry, which was one of the largest in the history of MNRE. It has an annual budget. It has an overall budget of 75,000 crores, and it is to be deployed over the period of 3 years. There is another scheme of PM Kusum, which has been now taking off very well. So with the kind of ecosystem that is developed, the cost of solar has improved. But one more thing that the government of India has done with the help of the Ministry of Power and Ministry of New and Renewable Energy is the green open access rules. It also allows the industry now to use solar or wind, and I can specifically talk of solar, to have to use solar energy into their overall electricity mix. And therefore, these distributed solar energy projects can help the developer also to use this for various purposes, not only to use them as an auxiliary fuel or auxiliary power for all your operations, but it also makes the project more viable, makes the project more greener and much more reliable and independent of the linkages of variety of the cost of electricity that increases year on year. So I would like to place this before all of you that while you are doing and conceiving your designs of bio CNG projects, you can also consider adding the solar, as I was mentioned, that there is ample land that is available across your project. So you can use captive solar based projects as well as, and I can also mention Shuklaji sir, I think over the last couple of years, the cost of storage also has drastically reduced. Now that is now enabling all of us, enabling the developers to look at a flat curve of solar of energy available from a combination of solar and battery, which will give you the entire power, firm power that you need to power your applications. So this is the kind of developments that have been happening across the world. And we, through the Indian Biogas Association, I would appeal to the Indian Biogas Association that you should take all such case studies into your into practice and try to bring on some kind of bulletins or some kind of literatures that will enable all your members and even the non-members who are looking at the technology aspects, who are looking at cost reduction, who are looking at becoming 100% green when they're doing their bio-CNG projects. So that is one aspect I just wanted to talk to you. I'm happy that Gaurav, you have taken lead in getting this program forward. You have been a very passionate lover of biogas, as I know. We keep on talking, engaging. My best wishes to all your future vendors, and I would be very following the presentations from all the other delegates who have joined this eminent panel. All the best to you, and look forward to a very fruitful engagement over the next couple of hours. All the best, and happy to get all the details as you get from the panelists as well. My best wishes. All the best.
Thank you. Thank you. Thank you, Jagdali Saab. Mansa, I want to thank Jagdali Saab has leave for another engagement today. So I thank him on behalf of Indian Biogas Association for all his support, which we have been getting. And you have rightly mentioned that the hybridization of solar and bioenergy and biogas is really very important. So as we are going to think and have the small interventions, how it can be integrated with the biogas especially. And I would also request you to, since you are now at the helm of the affairs in MNRE for solar, so what I have been for very long thinking that since solar farms and solar installations anywhere, power plants, they are having also a lot of land. So my vision about that was that if we can integrate the bioenergy there, then the storage, as you have mentioned, the storage part can also be taken care of by the biogas. And the problem of land, which will be ultimately there for the power and energy projects, can also be solved to a great extent. So my urge would be that in your planning of things, you can just have a hint so that the promoters are coming up, a new class of promoters are going to come up, will be the hybrid energy providers instead of only solar or biogas energy providers. So thank you very much for joining and blessing and guiding the audience today.
Thank you, sir. Much appreciated, and I will surely take that point forward, sir. Thank you so much.
Okay. Thank you. Thank you.
Thank you so much, Jagdali sir. Your insights were absolutely wonderful, and congratulations to all of us for this largest scheme in the history of MNRE, aiming towards 100% green concept that we all are dreaming about. So now our next eminent speaker is Mr. Vijay Kumar. Before I request him to share his thoughts with us, it is my pleasure to introduce him to all of you. Vijay Kumar sir received his bachelor's degree in civil engineering from NIT Jamshedpur and his MBA from Utkal University, Bhubaneswar, both in first class with distinction. After superannuating from Indian Oil from the post of GM, Alternate Energy Division, Corporate Office, he is currently working as consultant for CBG projects for Indian Oil, and is also the Chief Technical Advisor with Indian Biogas Association. He has extensive experience in oil and gas industry and worked in various departments of Indian Oil like engineering, vigilance, and business development. He was in charge of waste to energy vertical of Indian Oil as GM Alternate Energy Corporate Office Indian Oil, and in this role he was instrumental in conceiving and drafting all CBG and SATAT related policies or frameworks for its pan-India launch on behalf of the MOPNG. Welcome, sir. Over to you.
Thank you very much. Thank you. Thank you. Good morning, everybody. Good morning. Today's session regarding biogas purification system. So I will just share my screen with you. Is it visible? Screen is visible?
Yes, sir.
Okay, thank you. So today's session, I will just elaborate about biogas, how purification helps in improving the biogas quality, why it is required, what are the methods to purify, what are the impurities, and to what degree we need purification, what are the specifications required to meet the Indian standard, and what are the benefits over each system with other system, other
Sir,
technology.
I'm really sorry to interrupt, sir. Really sorry for the interruption. So we request you to kindly put it on presentation mode, sir, like full screen mode for
Okay.
better visibility.
Okay.
Yeah.
So my session will include mainly regarding purification system of the biogas, how this biogas generated out of waste stream is cleaned to make a useful energy, clean energy. And to start with my presentation, I will just start with what is biogas. Basically, biogas is generated out of anaerobic digestion of the organic materials like plant, vegetables, organic waste material like food waste, agriculture waste, vegetable waste, waste from sugar industry, etc. And these are put into digester. Pre-treatment is done before putting in the digester. And after pre-treatment, as per the waste quality, suitable pre-treatment is done. And these are put in the digester. Digester is nothing but a vessel in which anaerobic digestion takes place. And digestion time ranges depending on the technology utilized for converting into biogas. Depending, it's ranges between 10 days, 20 days to 30 days, 35, 40 days. It varies. And within the 40 days, 10 to 40 days, biogas is generated. And this biogas is mainly containing methane, carbon dioxide, and hydrogen sulfide. So we need methane as a fuel. And so carbon dioxide and hydrogen sulfide is to be removed, which is considered as an impurity. So methane is mainly 50% to 65% depending on the technology utilized, and carbon dioxide is also ranging between 35% to 50%. Hydrogen sulfide is very minimal, 0.3% to 3%. So this is the equation. Organic waste put to digester, and anaerobic digestion, mainly methane, carbon dioxide, and hydrogen sulfide, it is produced. And when this is put to purification system, after purification and compression, it is called compressed biogas or methane, which is more than 96%. More than 96% methane. When it is taken into filled into cascade, it is CBG, taken to retail outlet for selling as a auto fuel also. And this is called compressed biogas or CBG. Then a specification required for compressed biogas as per IS 16087 2016. This is minimum methane quantity is 90%. But we insist for more than 96% because compared to CNG, you see the CNG side by side specification is also given. CNG specification is as per IS 15958 2012. And here, beside methane, other higher version of carbon is also there as a fuel, which is ethane and C3, C6, higher version of carbon is there. 6%, 3%. So minimum we insist for CBG, it should be 96% so that it matches the CNG quality. Because maximum carbon dioxide permissible in CBG is 4%. So if we maintain CBG methane content as a 96%, then only it will matches the CNG property. Otherwise, if we matches as per IS specification of 90%, then some other impurity like nitrogen or carbon dioxide will increase. oxygen will also increase. So it will not be matching the CNG quality. So we insist, although it is permissible is 90%, but we insist that minimum purity of methane in CBG should be 96% so that it's comparable to CNG. And you will find that sulfur, both the CNG and CBG sulfur quantity is 20 ppm. Moisture in both the specification it is 5 ppm. Oxygen maximum 0.5%. Whereas there is a minor difference in carbon dioxide, whereas in CNG it is 3.5% allowed, where CBG it is 4%. So 0.5% variation is there, but maximum carbon dioxide, then oxygen and nitrogen is maximum 10%. And since that reaction takes place in anaerobic condition in production of CBG, so air is not there. So nitrogen, chances of shipping nitrogen is not there. So that's why also methane minimum 96% is required. We are approaching the IS code for revision in methane percent, so that it should become 96%, so that it is compared to CNG. Now next slide. What are the process of what are the impurities present in purification system? So basically impurities removed from raw biogas is hydrogen sulfide, removal of carbon dioxide and removal of moisture. These are the main three removal purification system done while purifying the raw biogas. And we will come to each of the section, how hydrogen sulfide is removed, how carbon dioxide is removed, and how moisture is removed. So there are various process of removing hydrogen sulfide from the raw biogas. One method is biological fixation. Second method is iron chloride dosing, and another is water scrubbing. Another method is activated carbon processing. Again, iron chelating method, then amine process. So one by one, just I will explain how biological fixation is done. So removal of hydrogen sulfide by biological fixation. Biological fixation, also known as bioremediation or biofiltration, is a process by which living organisms such as microorganisms are utilized to remove or transfer pollutants from the contaminated biogas. Biogas purification, biological fixation refers to the use of a specific microorganism to metabolize or convert harmful compound of hydrogen sulfides into less harmful inert form. Biological fixation harness the natural capabilities of certain basically bacteria are used, microorganism is used. Raw biogas is processed through the bed of this microorganism, which absorbs the sulfide content, hydrogen sulfide content of the raw biogas, and converts into elemental sulfur or sulfur sulfate compounds, and it makes the raw biogas free from the hydrogen sulfur. So this is one method of removing hydrogen sulfur, biological fixation. Second is chloride dosing. Chloride dosing is basically some iron chloride or other chloride are used, and hydrogen sulfide containing raw biogas is passed through this compound, where reaction takes place, where in reaction this iron chloride converts to sulfur component of iron, and hydrogen hydrochloric acid is as a byproduct, it is coming out. So basically chemical reaction takes place when a bed of this iron chloride is dosed through the raw biogas segment, and due to chemical reaction, this hydrogen sulfide is removed from the raw biogas section. So this is one of the purification method. Another purification method is of removal of hydrogen sulfide is through water scrubbing. In water scrubbing, basically stream of biogas is passed through water columns. So water is sprinkled through this water towers are there, where water is sprinkled through the raw biogas section. And this since hydrogen sulfide is soluble in water, so this hydrogen sulfide gets dissolved in the water, and sulfurous acid or bisulfide ions are made out of the reaction, and this raw biogas is made free from hydrogen sulfide. So this is one of the method of removal of hydrogen sulfide from the. Then removal of hydrogen sulfide by activated carbon. So in this process, activated carbon bed, which is porous carbon, raw biogas is containing hydrogen sulfide pass from this bed of activated carbon, and then in this process also these hydrogen sulfide molecules get absorbed in the raw in the carbon bed, activated carbon bed, and this is removed. Hydrogen sulfide is getting removed. So this is one of the method. Then iron chelating. This is most common method, iron chelating, because hydrogen sulfide reacts with iron chelating, which is basically ethyl dimethyl acetic acid, which reacts with hydrogen sulfide to make the complex iron ion, and this reacts with hydrogen sulfide to form remove the sulfur from the biogas. So this is the most common treatment done, because this can be again used, and chelating can be replaced with new agent, and this is very easy method. So maintenance is easy. So these are the most common method of removal of hydrogen sulfide from the biogas section. Then amine scrubbing. The amine is also same process. Instead of iron chelating and all, amine solutions are there. Basically, amine solution dissolves the hydrogen sulfide, and then it purifies the hydrogen sulfide from the raw biogas, and makes the raw biogas free from the hydrogen sulfide. So these are the some of the method of removal of hydrogen sulfide from the raw biogas. Now we will come to removal of the carbon dioxide from the raw biogas. So again, 2, 3, 4 methods are basically 4 methods are there: absorption, adsorption, then PSA, pressure swing absorption, membrane separation. So absorption method, basically amine scrubbing we are doing, water scrubbing we are doing, then pressure swing absorption method, and then membrane separation. So these are the basically 4 method of removal of hydrogen sulfide, carbon dioxide from the raw biogas. So one by one, I will just explain. In this method, this amine solutions, again, amine solutions are utilized to absorb the carbon dioxide from the raw biogas, and biogas is passed through the tower of the amine solutions, where carbon dioxide gets absorbed in phase manner, and due to chemical reaction, this absorbed amine then again released and regenerate the absorbed for reuse. So temperatures and all are used to increase the temperature of the amine, and due to temperature, this again it is absorbed and then again deabsorbed. So this way amine scrubbing function. This is the very costly method. Capital cost is also, because after 3-4 months again amine has to be replaced and refilled. So not very commonly used, but purity of the biogas in amine process is very high, up to 99%, more than 99% purity is maintained. So when high purity is required, then amine process is used in purification of the biogas. This is just a diagram of how this function. Absorption column is there. Raw biogas is passed through this absorption column. And then heat exchanger is also there. Exhaust is there. Regeneration column is there. And raw biogas after purification, it is coming out and again put to compressor and then filled in the cascades. Then water scrubbing. This is very commonly used water scrubbing. Water columns are there. Similar to amine, it is water is used as a scrubber, and this water acts as a aqueous solution which absorbs the carbon dioxide and makes carbonic acid and bicarbonate ions. And in water scrubbing, this carbon dioxide is dissolved, which can be regenerated through treatment of carbon dioxide recovery system. Water scrubbing is widely used method for carbon dioxide removal from biogas due to its simplicity, effectiveness, and cost efficiency. Capital cost is very low. And since replacement of amine is not required, water is easily available without any much cost. So it is very highly used. But here also the loss of methane is quite high in water scrubbing, up to 6%, 7%, 10% also. So that is making the choice of use of water scrubber as a less choice. I will discuss also what are the different
excuse me, sir.
Yeah.
Sir, just a gentle reminder, sir. Like we have just 2 minutes to go.
Okay. Only 2
Yes,
minutes to
sir.
go. Okay. Okay.
Yes, sir.
So I will just run down. So this is
Right,
systematic schematic diagram of water scrubber. Then PSA method, pressure swing absorption method. This is basically zeolite is used or activated carbon is used as a molecule to absorb the carbon dioxide molecule from the biogas, and due to different pressure, pressure swing, as the name suggests, pressure difference acts as a absorbance of carbon dioxide and again deabsorbing. So different cycle is there, and this is very commonly used method. This is just diagram of PSA this thing. So just raw biogas interns, and just to have an idea how it is acting. Here also quite a significant loss of this, but now this thing technology has come in which the loss of methane is recovered through making it double use of PSA system, increasing the column, loss of methane is recovered. Then membrane separation is also a highly used membrane. Physical membrane is put into the raw biogas passing passage, and this membrane separates the carbon dioxide, and filtered methane is we get the filtered methane. So this is highly used, most commonly used in European country. This is a highly most popular choice. So now I will come down to how this the schematic diagram, how it looks like. Then high pressure side gas separation membrane, then low pressure side after filtration pure methane is left. How moisture is removed. So moisture is removed. 3-4 methods are there: condensation, absorption, membrane separation, drying towers. So by this method, moistures are also removed. mostly we cool down the gas to minus 10 degree, 15 degree, so that this ice forms out of the raw biogas moisture, whatever moisture is there, ice is formed. So that is the most popular choice of moisture removal. So these are the basic purification. How selection of the various technology, how we form the selection criteria. Basically, selection is done based on requirement of the purification. How much purity of the gas methane you require. So that is the prime criteria. How much purity you require. Availability of the technology. How easily technology is available. So that is the second criteria. Cost of maintenance and ease of maintenance. This is also a most important criteria that ease of maintenance and cost of maintenance. How operation and maintenance cost is there. Then cost of operation, how much electricity it gets consumed while operating the purification system. That is very vital criteria. Methane loss is most important criteria, because if the loss of the methane in some of the method like water scrubbing, other method, if loss of methane, membrane separation also, PSA also, if the loss of methane is up to 15%, 20%, in some cases up to 30%, as the purities requirement is more, say 96%, 98% methane purity is required more and more. So loss of methane is more and more, up to 30% loss of methane is there. So recurring loss of methane is most important criteria. Capital cost comes least. So with this, I conclude my session. I hope I made it in time. Thank you. Thank you. Any questions?
So thank you so much, sir, for sharing your insights with us and these important concepts with us. They were really helpful. So our next eminent speaker is Mr. Nikhil Khote. Nikhil Khote is presently associated with United Nations Industrial Development Organization as National Project Coordinator for the project Organic Waste Streams for Industrial Renewable Energy Application. And the project is funded by Global Environment Facility and is being implemented in partnership with the Ministry of New and Renewable Energy. He's a postgraduate renewable energy professional with more than 2 decades of experience in technology and product design and development, project management and training, capacity building in the renewable energy space, including solar PV and thermal, biogas, fuel cells, and small winds. So he comes with a versatile experience. Welcome, Mr. Khote. Over to you.
Good morning, all. Am I audible?
Loud and clear, sir.
Okay. Thank you for inviting me to this webinar to present some of our experiences on innovations in biomethanation, waste to energy. I would start my presentation by Can you see this screen? You see my screen?
Yes, sir. We can see your screen, sir. Kindly go ahead.
Yeah, so I would today talk on innovations in biomethanation waste to energy sector in India. UNIDO, in partnership with MNRE, is implementing project organic waste streams for industrial renewable energy applications in India, which is a JET-funded project. One of the activities of this project is to support commercial demonstration of innovations. Under this project, Project Loan Interest Subvention Scheme was launched in August 2021. The objective was to reduce financial burden of low interest rate on innovative demonstration projects and scale up the investments in innovative industrial organic waste to energy biomethanation technologies and business models in India. So far, there was no specific support available to demonstrate or the commercialization of innovations for biomethanation. There is a support available under MNRE's R&D program, but that's a limited support for demonstrating at a lab scale or pilot scale. Under this scheme, after deliberating with stakeholders, uh, focused areas for innovations were selected, which are primarily like feedstock processing and management, plant equipment and design, biogas scrubbing and upgradation technologies, biogas for bio-CNG applications and innovative business models, value addition of digested manure, new and advanced biochemical processes. These are like few of the areas out of many which stakeholders found that would make larger impact to promote or to boost the sector. The key features of this interest subvention scheme was that uh, the project loan interest subvention was up to 5% for the tenure of 8 years. The choice of banker, like the project developers are free to apply for loan in any recognized bank by any bank by recognized by RBI. Direct disbursement of the applicable interest subvention to the project loan account, as a capital interest subvention, and interest subventions applicable to all three categories, which is in line with the ministry's program. Under this project, more than we received about like 44 applications. As you can see, the classification based on the sizes. The maximum number of applications were for of the capacity of 1 to 2 megawatt equivalent electric power generation, which is roughly about 5 to 10 tons per day bio CNG. The cost per megawatt or per megawatt electric power equivalent for 5 tons uh, per day bio CNG production is shown in the graph. The average cost up to 10 TPD capacity in the range of 25 to 35 crores per 5 TPD. And the larger projects obviously have about 18 to 20% lesser cost, which is, than the 4.8%. Uh, more than, I mean, about 25% applicants participated in more than 4 innovation areas to demonstrate. So this is the kind of applications that were received under this subvention. All these applications were scrutinized and then evaluated by the expert appraisal group in a competitive manner. And then 4 projects got selected under this support scheme. These are like, as you can see, 2 of them are in Haryana and one in Punjab and one in Uttar Pradesh. All 4 put together, the cumulative capacity of energy generation is about 64,000 of meter cube of biogas generation per day, which is close to 5 megawatt electrical equivalent electric power, and about 25 tons of bio-CNG production. The Indian Renewable Energy Development Agency is the fund manager and will administer the applicable financial support to these projects upon their successful completion. These are some of the innovations which will be demonstrated by these projects: batch type, solid state, anaerobic digestion, or dry digestion. This will be demonstrated by the project in Punjab, Fatehgarh Sahib district. Biological desulfurization, medium pressure swing adsorption, uh, layered storage of pressed mud and paddy straw using Goliath crane is kind of like a interesting innovation, I would say. And as you can see, there are like few more innovations. I will not go each of them. Elemental circle recovery, valorization of. So primarily they cover all 6 areas which were selected under the scheme. Uh, so, what is the way forward to promote innovations? How does the landscape of biomethanation looks, and what are the potential areas. The complete landscape of biomethanation can be classified into three segments. One is on the feedstock side, which is upstream side. The second is biomethanation technology, which is for plant engineering, design, and all. And third one is the downstream side, that is the energy and augmented organic manure. In all these three sections, the innovations can be implemented or done through technology, process, applications, and different business models. Uh, from the applications we receive, uh, we have observed that the feedstock under the feedstock management, the transportation, aggregation, segregation, these are the areas where there is tremendous scope for innovation, especially for the feedstock like agricultural waste. As all of you know, the paddy straw is a major issue, and there is a lot of innovation that can be done for the collection, segregation, aggregation for the paddy straw. The second interesting innovation area could be, or promising area could be, feedstock storage, feedstock pre-treatment. As all of you know, the paddy straw is kind of like a complex feedstock, and it needs pre-treatment before taking it for biomethanation. So this area also has a tremendous potential for innovation, especially for agricultural feedstocks. And the third area is, creating innovative business models for promoting energy in the form of bio CNG, biogas power, or biogas as a biofuel, and then also liquid fermented organic manure and solid fermented organic manure. What are the drivers for innovations? Last year, Global Biofuel Alliance at G20 Summit in India strengthened the support for potential demonstration of innovations. The government initiatives, including SATAT, National Bioenergy Program, Fertilizer Control Order to promote bio-CNG and fermented organic manure, will certainly catalyze the innovations. Uh, on top of all, the at present, estimated energy generation potential from the waste streams is roughly 9,000 megawatt, which is close to 45,000 tons per day bio-CNG production, which is huge. And this estimate does not include the feedstock from agricultural waste. So there is tremendous scope for innovation, the development of technologies, business models in this case of biomethane, and even to take it for commercialization. So what project developers should aim while doing the innovations? Create opportunities to provide competitive and comprehensive energy solutions for industries, agronomies, and communities. Reduce the dependence on fossil fuels to curtail the pollution and protect the environment. Reduce the important import bill by minimizing the import of crude oil and natural gas, and support the Make in India movement, and also create uh, larger employment opportunities. Uh, Way forward to promote innovations in biomethanation, I would start with certificate of readiness of innovation for its commercial demonstration issued by recognized and designated institute. Right now, the innovations are designed or tested at pilot scale, lab scale by the project developers or the innovators by themselves, and then when they need to be commercialized, a lot of scaling up need to be done. and it's a complex process. So, which need to be evaluated by a certified, recognized institute, any institute like academic institute or like organizations like eBay, and they should give a certificate of readiness of innovation which is ready for commercialization. So that will increase the confidence of bankers to support or to finance those projects. Financial support such as loan interest subvention, this is absolutely required because uh, innovation when innovation is commercialized, there is always a big apprehension of the bankers whether this will work or not, to what extent it will become successful, and uh, cover up that they demand higher interest rate, which actually impacts the economic viability of the projects. So yes, special financial support in terms of loan interest subvention or in any other innovative financial instrument is specifically required for the demonstration of commercial demonstration of innovations. Along with that, support from agricultural universities is also required to promote solid and liquid fermented organic manures through their training programs for the farmers. This would, uh, I would say, simplify the penetration or commercialization of fermented organic manure, and this could be like a big support or big help for the project developers to sell their fermented organic manure FOMs. Policy intervention to set up microgrids for the distribution of bio-CNG as a replacement of LPG for cooking in rural or suburban areas. Just like Satat, where bio-CNG as at present, there is a policy that oil companies shall buy bio-CNG from bio-CNG plants to sell it as a vehicular fuel from their retail outlets. Similarly, this bio-CNG can be used as a cooking fuel, and it would be interesting to set up or to have microgrids of bio-CNGs at rural or suburban areas. But definitely, this would require a policy intervention, just like Satat's a new program shall come up, and then even like oil companies who are specialized in CGD and all can help in setting up these microgrids of bio-CNG for cooking applications. Thank you so much. These are the some of the pictures of four selected projects. I'm happy to take questions if there are any.
So thank you so much, sir, for sharing that valuable information with all of us and especially showing us the way forward to promote the innovations in the biomethanation sector, which is very much need of the hour. So our next eminent speaker is Dr. Kees W. Kwan, who's a senior expert on bioenergy and circular bio-based economy at the Netherlands Enterprise Agency, a department of the Ministry of Economic Affairs and Climate in the Netherlands. He primarily links researchers and industry to help develop the circular bio-based economy and bioenergy in the Netherlands and abroad. He's also a member CEM BioFuture Initiative and leads the Innovation Mission Integrated Biorefineries as Mission Director. Welcome, sir. Over to you.
Thank you very much for this kind introduction. Am I audible?
Loud and clear, sir. Kindly go ahead.
Okay, thank you very much. So now I also would like to show some slides. So I hope that when I start with showing my slides, that the previous one will stop presenting. So maybe the previous presenter could stop presenting. Thank you very much. Now I will try again. Yes, I'll use this one and put it in presentation mode. I think this should do, isn't it?
Yes, sir.
Okay, thank you very much for this kind invitation to present to you about the developments of upgrading biogas to biomethane. Actually, in the Netherlands, we call biomethane, we call it green gas. That's, let's say, the local name for biomethane, but we are talking about the same thing. So it's really a pleasure to talk about this. We are already, let's say, looking at the long-term development on this in the Netherlands, because we see that in the Netherlands, this is really part of, let's say, the overall energy system. Next slide. Wait a moment. Page down. Yes, this one. Yes. We are in the Netherlands, we have a very active policy to introduce renewable energy. So it's about renewable electricity, but all our houses in our country are also connected to the natural gas grids, because natural gas is a very dominant energy factor in the Netherlands. So this, of course, originally came from the earth, but we want to reduce the fossil resources. So we are now looking into renewable gases. So for that reason, we are looking into the biomass, use it and produce either through anaerobic digestion biogas from it, or we can also produce through gasification syngas, and then we can both methanize it. So we can, through methanization, we can produce from the biogas or from the syngas, the biomethane. So the upgrading is, of course, possible. It is available here in our country, and it is also being implemented. And I'm going to tell you a little bit more about that. So in our country, we are one of the European countries. We are in the northwest of Europe, so close to the United Kingdom. And we are a country with about 18 million people. So we are very densely populated. But even in that situation, we have a very ambitious goal to realize 32% renewable energy in the year 2030. And at this moment, we are at 15% renewable energy. And well, this, of course, it is already an achievement. Of course, it took a long time for the 40 years that I have been working. When we started at 1%, we went up to 15%. So in the next 6 years, we will now go to the 32%. So it requires an enormous effort. An important part of that 15% renewable energy comes from biomass. That is mainly for heating. Totally, it comes up to 280 petajoule. Actually, at this moment, we recently crossed the border of 50% renewable electricity. And that's because we have a lot of solar and wind. But of course, electricity, it's only about a quarter of our energy supply. But at least that is already for 50% renewable. And biogas, at this moment, it is about 7 petajoule. And that is, this 7 petajoule is about 2.5% of the 280. But of course, it's a very crucial element in our renewable energy system. They all, in these different methods, have to contribute. So let's look at the biogas production, that how it happened over the last years. As I mentioned, 1990, we were only at a very small amount. It was mainly landfill gas that we were using. And after that, we started with biogas production. And you can see that till the year 2010, the light blue, it was all made, we used it for the production of electricity and heat. And after 2010 and up till now, it is the green gas production. So the dark blue, it's the green gas production that has been realized over the last years. And this, of course, needs to grow more. And actually it does. last year we have seen a 23% growth. So it's really growing, and we have our goal in the year 2030. You can see on the right hand edge in this graph to move up to 1.1 billion cubic meters. So that is the 1.1 from the 35 that the European Union is aiming at. But in the Netherlands, we're taking our share, and that is this 1.1 billion. It could be more, but it takes quite some time to realize projects and so on. So that's where we will move. And at this moment, we have about 80 projects that produce biomethane, and all our biomethane is fed into the grid. We have our natural gas grid, so the biomethane can be used and can be fed into the grid. Of course, you could also do other things like production of compressed natural biogas, or also different ways using it. But that's what we mainly do at this moment, because that's also how our, let's say, support system works. We have our policy and we support it. And at this moment, we support it financially through there are two ways of support. One way is the so-called SDE++ scheme, where we give, let's say, a small amount of money to the producers of the biomethane when they feed it into the grid. So there is a measurement system and there is a control system that you can measure how much they feed into the grid. And then for each amount cubic meter or that they feed into the grid, they get a certificate. And this certificate can be used to get financial support from the government. So that is going through my agency. And actually, we make in advance 12 years contracts for the production of biomethane. And actually, last year, we have contracted about 1 billion euro for this 12 years production that we will have in advance. So that's one way for financial support for the producers of biomethane. The other way is that they can also use this certificate, this guarantee of origin, and they can sell it in the market for, let's say, the mobility market, because we have an obligation to produce a certain percentage of renewable biofuel or renewable energy in the transport sector, and they can use also that certificate there. So it is one way or the other, either trade it or use the financial support from our government. We are now looking into a new scheme, and that is for this 1.1 billion cubic meters that we want to reach in the year 2030. We want to put an obligation on the gas distributors. So all the natural gas distributors, they will have an obligation to realize a certain percentage of this gas should be then renewable gas. And that is still something that is under development, but that's the way how we look at it in the future. So that is how we have a market, and that's how we have realized this growth in the biomethane production. And as we call it, it is the green gas production. So we have a lot of, let's say, technologies available in our country. We have a lot of, let's say, suppliers of equipment. So it can either be biogas installations, but it can also be upgrading. So, for example, here we have the company DMT. They are really a global supplier, so they go to the USA and overall everywhere in Europe. They install their systems for upgrading biogas into the biomethane. And the most favored solution actually here in the Netherlands, it is at this moment, it is the membrane technology. Already in the year 1992, we started with the pressure swing absorption, and I still remember that system from a long time ago. It was very, let's say, operational. It worked well, but unfortunately, the methane recovery was lower. So the highest efficiency of methane recovery from the biogas actually at this moment seems to be achieved with these membranes. So that is now the favored technology. And of course, this membrane technology, there's a lot of knowledge on how to do this. And another company here, it is the company Host. They also have a similar system that they develop, and it is also sold in different countries, and they also sell it worldwide. Now, for these companies, they look, of course, for solid markets, and of course, maybe collaboration with India could be a possibility. And I think it's very interesting to see the developments as it was just presented by you in India, all the technology development you have. But companies from the Netherlands could also be interested to collaborate with you. And in that respect, we have several platforms. We have the so-called platform Green Gas, where all these different companies they join. We have also a platform Bioeconomy, where we look into the development of the bioeconomy. So the platform Green Gas is more locally oriented, and the platform Bioeconomy is more, let's say, internationally oriented. So basically, what we want to do is to see if we can organize a mission to India, and that is scheduled in October of this year. And we hope that also, let's say, jointly with your association, we can look at, let's say, possibilities for collaboration. And that's still something that is open, but I hope that that can be materialized in the future. And with that, I would like to come to my conclusion. I think we really have to look at all the different options, really try to reduce the CO2 with all these options. And we need solid markets for electricity, but also for heating, also for transport, for renewable solutions. So we have to improve these markets, see that the right technology fits into it. And then we see in the Netherlands that biogas, and specifically when it is upgraded to biomethane, is a substantial part of renewable energy. And it can also fits very well in what we call the circular economy. And it was already explained in the opening session in agriculture, to make agriculture more circular. We think there are a lot of, let's say, opportunities. And I hope that we can realize some kind of collaboration on these topics in the future with you. Thank you very much for your attention.
Thank you so much, Dr. Keys. It was a wonderful presentation indeed, and we are so delighted to learn the fact that 50% of countries' energy is coming from renewable sources. So that was great to know. So moving on to our next eminent speaker, we have Dr. Tushar Bhaumik, who's a PhD in cryogenic engineering from IIT Kharagpur and is super active in the field of cryogenics for the last 4 decades. Now, he's an executive member of Indian Cryogenic Council. At MVS Engineering, he works on tech support in the field of biogas and cryogenic system development. Now, before I invite him, I just request the previous speaker to kindly unshare the screen so that the next speaker can present the screen comfortably.
Sorry.
So we have Dr. Tushar for the next 10 minutes. Over to you, Dr. Tushar.
Good morning. First of all, warm welcome to you all in this seminar. And I'd like to share my special thanks to IBGA for providing us opportunity to share some thought process in this seminar. Let me share my presentation first.
Dr. Tushar, please go ahead.
Yeah, just a minute. Just a minute. How to share this? Option to share screen. Just this is share now. This is share.
Right, so we can see your screen, sir. Kindly put it on full screen mode, the presenter mode.
Okay.
Great, thank you, sir. Yeah.
Thank you. Thank you. Thank you. Sorry for the ignorance. Basically, I'm not very smart in this kind of presentations. But anyway, first of all, actually, from MBS, what we would like to share some thoughts about biogas upgradations and liquefactions. I'm associated with MBS for last 1 year, and specifically working on this subject. If you see MBS Engineering as a company, it is founded in 1977. It's based in New Delhi. The competence of this company is primarily on industrial gas plants and enabling globally on-site gas production machines. So it has got a kind of a manufacturing capability as well as an integrated engineering capability. So 200 plus people are working in these things. So for MBS, since they're having last 5 decades in gas businesses, so it was quite synergistic to enter into biogas segments, which will be really going well coherently with the company itself. If we see the current biogas landscape, generally what is happening in India is biogas production, which is just by anaerobic digestion of feedstocks. We have got a purification mechanism, which is primarily being done in India, water amine scrubbing, PSA and BPSA, these kinds of technologies. And after the purifications, the biogas has been stored and transported by compressors in cylinder casket after compressions. So this is the typical landscape which is happening till date in India. So from MBS, if we wanted to value add in these processes, what basically lies ahead? So we perceive there can be options, means okay, the way it's going on, it's fine, maintaining a status quo, and there can be possibilities. Let's try to improve the technology and adopting new alternate technologies. So if we see on the biogas value chain, there are a couple of challenge areas. First is on the feedstock, resourcing feedstocks. That's one of the challenge area. Purification is like making it economic purification technology and ease of operation. Those kinds of aspects need to be tackled. And also an important point, distribution of the biogas. Distribution is an important aspect which is coming up. In India, we have come out with a very huge capacities gas plants which need to be connected either to the grid or to the user point through an economic option. So that in that respect, we feel that there is a good possibility to go into the liquefaction format of biogas for this economic storage and distribution. And why we are looking for such a kind of a change or proposing such a kind of a change, the whole address is to lower life cycle cost. When we are making any kind of economics and costings, we're going to the instant part of it. But then I think it would be more pertinent to go for a life cycle economic calculations to adopt a particular technology. There are tangibles and there are intangibles. So obviously we have to look into those, both of them. When we propose such a kind of a technology like gas purification through membranes and liquefaction mode, we are talking about lower footprints, because these kinds of technology what we are talking about are smaller and modulars, and this can really take a kind of a lower installations area, so you don't have to go for land acquisitions and those kinds of activities. And obviously this will help in efficient logistics, storage and distributions. If we see the technology of purification which is going on as on date, there are water amine scrubbing, absorptions and membrane. Membrane is the latest technology which we are proposing. If we carry out a kind of a comparisons on different aspects, if you see on the purity of the membrane, okay, it's moderate to high, high and moderate to high. So for purity of membrane, all processes has got a scope of go for high purity, like low methane loss. Energy efficiency can be for membrane is very high, because it's really a very efficient process of separation of carbon dioxide primarily. Installation footprints, as I mentioned, in membrane separation, we have got the smallest installation footprint. Recurring expenses are also very low in membranes. Maintenance intervals are also low in membranes. Scalability is also a very interesting factor which is helping in membranes, because the membranes can be added on to increase the capacity and the combinations, and the reverse is also true. When you wanted to kind of turn down or reduce the capabilities, so membranes numbers can also be reduced during the operational stage itself. And obviously in membrane technology, operators involvement is lowest. Very little operator intervention required. Interventions. So primarily membrane separations really has those kinds of falling advantage, no moving parts, ease of operation, highly scalable, highly expandable, and very easy turnaround. Presently in India, in worldwide, there are the following global players who are really in the field of supply of very good quality membranes: Air Liquide, Air Products, ARN, and Evonik. Incidentally, ARN Korea, we have with us their representative Daltech today, and we can listen to them, listen from them a little bit of their technology. And obviously later in the presentations after me, Evonik is already there in the panel, so they are going to share. So what I would request, can Mr. William for Evonik join from this? William.
Ask him to spotlight Mr. William.
So can we go ahead with the next speaker, sir?
Yeah. Actually, can we get Mr.
William?
Mr. William to be in the panel, because
Sure.
yeah, please.
So next, I would like to welcome Mr. William, who is manager at ARN, and he leads sales activities with the nitrogen and biogas upgrading membrane markets across Europe, Asia, and South America. So before I welcome him, sir, I request you to kindly unshare your screen so that Mr. William can very well share his screen and share his thoughts with us for the next 5 minutes.
Stop share.
Mr. William, over to you, please. Kindly unshare the screen. Thank you, sir. Mr. William, over to you. Mr. William, we sincerely hope we are audible and there's no technical glitch from your end. Are you able to share the screen? All right. In the meantime, can we have Mr. Arjun Coinreddy, who's the MD of Sterling Cryogenics BV, the Netherlands, and has decades of experience in the field of biogas during his work tenures in Africa and the Netherlands. He remained the driving force of Sterling for successful execution of about 20 projects in biogas liquefaction over Europe. So can we have Mr. Arjun, please?
Yes, good morning, or in the meantime, probably afternoon at your end. I just woke up, so for me, it's still morning. I think we're jumping a little bit in the in the presentation of Dr. Boomwijk. But let me try to share from my end what I wanted to share with you today. Let's see where it leads. Is this visible now?
Yes, sir. The presentation is visible. Kindly put it on a presenter's mode or the full screen mode. Thank you, sir. Kindly continue.
Great. Okay, like I said, we are jumping a little bit in the presentation of Dr. Boomwijk because after purification and upgradation to biomethane, the next possible step is to liquefy the biogas, and that is typically what Sterling takes as his core business. On the screen, you can see on the right-hand side this yellow machine. This is the core technology that Sterling has developed. And one of such machines is in the core producing cold, and the cold is practically being used for liquefaction of all kinds of gases. As an introduction, we are based in the Netherlands, in the town of Eindhoven. There's a reason for that, because originally our company used to be part of Philips, and Philips takes its main seat in Eindhoven as well. Our company has been in business since 1954. At that time, Philips developed the technology, and ever since in those decades, we have been supplying our technology all over the world for all kinds of cryogenic systems. Currently, we are owned by a company from Italy called EasyTech. EasyTech is specialist in gas purification technologies, where Sterling is in cryogenics and liquefaction of gases. So together for the biogas industry, we form a very interesting team. Also in India, we've been always very active, and then mainly in the field of animal husbandry and all kinds of research projects. So, and that is typically for the production of liquid nitrogen on site for preservation for bull semen. A brief about our company structure. There's a holding company in Italy, and underneath there's different sales and production locations. So EasyTech is the gas purification part. Sterling Cryogenics in the Netherlands is the manufacturing and sales part. And then we have sales offices in the USA and in Scandinavia. In India, we are represented by MVS. Well, looking at the value chain that I think has been also discussed by previous speakers, we are typically in the downstream part of the biogas. So after production of biogas in the biogas plant, we look at how to monetize the actual molecule coming out of the biogas process. So the first step after biogas production, we call that upgrading. Typically, we remove the most of the CO2. So we remain with what we call biomethane, which is typically like 97-98% purity. And from there, we would have a CO2-rich stream and a biomethane-rich stream, a methane-rich stream. So the methane-rich stream can be liquefied. For that, it needs to be further purified, because we are looking at a purity of 99-point-something% in order to liquefy properly the molecule. Same can be said for CO2. I will leave this out of the presentation for today and focus mainly on the biomethane bioenergy production stream. So, like I said, what we do is we produce these yellow machines as our core business. One of these yellow machines produces typically 1 ton of LNG per day. That corresponds with 60 cubic meters per hour of biomethane intake. Or if you convert it back to biogas, that would be in the neighborhood of 130 cubic meters per hour of biogas. So in order to make the plant and the system suitable for the capacity that the biogas plant is producing, we put these machines in parallel. So by making steps of 1 ton per day, we can scale it up to maximum 20 tons per day, which is a considerable size for any kind of biogas plant. Very short on how this works. So the incoming stream is on the top left. The biomethane is coming in, is entering into a purification step. That is the last purification to take the last percentages of CO2 out, down to 50 ppm CO2, in order to properly liquefy the gas. The gas is being entered into the Stirling, and from there it's going to the transfer vessel. We prefer to liquefy at a bit elevated pressure, but your customers will not be very happy with high pressure LNG. So before we enter it into the transfer vessel, we flash down the pressure to the required pressure. Usually it's like 1.5 to 2 bar. The flash gas that's being created by that is being recycled upstream and passes through a heat exchanger in between to pre-cool the incoming gas. By setting up the process like that, we make the process lean and very energy efficient. Our experience, we have 70 years of experience in cryogenics and now more than 10 years of experience in biogas liquefaction. That it's a very energy intensive process, and making the electricity intake as low as possible is key to making projects feasible. And I would say especially so in the field of biogas. If biogas liquefaction is in the actual sense not so difficult, but doing it in a very efficient way is something that is more difficult. So this is a cut through of our machine. Very brief, this machine is driven by electric power, which make the crankshaft rotate, and this makes this piston move up and down. This section is filled with helium gas. So the helium gas is being expanded and compressed at a very rapid rate. This expansion of the helium gas produces the cold that we are interested in. That cold is being transferred over to this cold head, the copper block. The biomethane, or the gas that we try to liquefy, is being entered from the top and gets into contact with the copper and condensates at a certain moment at its temperature that it liquefies. So the main advantage of our system is that there's a separation between the mechanical part and the process part. So the process part is separated by this cold head, so that there will never be contact between the mechanical part and the molecules that we try to liquefy. So there can be also no contamination of the gas. This is an example of a plant that we have built in Italy, in the neighborhood of Milan. It is installed at a waste treatment facility, converting household waste into biogas and other kinds of materials to be reused. So if you look at the scheme of biogases coming from either household waste or agricultural waste, it's fair to say that household waste is the more difficult biogas, because usually that contains more VOCs and siloxanes and H2S and all the stuff in actual sense that you prefer not to have on biogas. So for that reason, our purification step is a bit more heavy than for agricultural biogas. We do a pre-treatment step, which is on the left-hand side, these two tanks that mainly takes out the H2S from the biogas. Then in the front end side of the plant is a combination of water scrubbing and membranes. The membranes are positioned in the container. The water scrubber step takes out most of the more difficult molecules to be separated, so the VOCs and the siloxanes. The membrane takes out mostly the bulk CO2, and from there the gas is being entered into the containers at the back end, and in there is installed the polishing step, so taking out the last percentage of CO2 and the liquefaction part. In this case, there's 5 machines of our system installed, so this converts back to roughly 500-600 cubic meters of raw biogas flow. As said before, we install that many machines that are needed to handle the biogas flow. So this is an example of a 2-ton per day plant. So there's 2 of our machines installed. And this is an example of a 10-ton per day plant. So there's 10 machines installed in a container. And you can see how small the footprint also of such a plant is, because one container can take 10 of our machines. And then in another 40-foot container is the purification equipment and the transfer vessels. So actually, with a footprint of 2 40-foot containers, that can accommodate a 10-ton per day plant. Well, if you look at the advantages of our technology in the landscape of liquefaction technologies in the industry, most important benefit that we have to offer is the energy efficiency. We can liquefy a methane gas at as low as 0.8 kilowatt hour per kilo LNG. Maybe that number is a little bit insignificant at this moment, but I can guarantee you that's a very low number compared to alternative technologies. Also, our cryogenerator is designed for liquefaction of down to minus 200 degrees centigrade, meaning that it can easily handle methane, and it can therefore also easily reach the temperature that the end customer desires. So minus 160, minus 155 degrees centigrade for methane is very possible. Another important benefit I wanted to mention, without being fully complete, is the modularity of the system. So that makes that the technology will always remain its energy efficiency. If you're buying as planned.
Sir, a gentle reminder. So sorry to interrupt, but a gentle reminder. We need to wrap it up now.
Yeah. If you give me 30 more seconds, then I'll be finished.
Sure. Thank you.
So the modularity makes that the system can be sized to the plant that the customer has, but also it will maintain the energy efficiency, because if the biogas plant is producing less biogas than it should, actually we can shut off one or two machines to accommodate the same flow. As a final slide, I would like to share with you this. We started with a commercial breakthrough in the biogas sector in 2021. And since then, we have done 22 projects. They're all in Europe, as you can see, and they range from 2 tons smallest to 11 ton per day biggest. Yeah, this is in Europe. This is becoming a serious industry, and our expectation is that this will also take off in other parts of the world, amongst others in India. So the rest of the presentation contains pictures of references plans that we have been doing. I think we will share the presentation afterwards with the audience. So any questions, feel free to ask.
Yeah, thank you so much, sir, for that insightful presentation. Next we have Dr. Sangeeta with us. I humbly request everyone to kindly mute themselves for swift communication. Everyone kindly mute themselves. Thank you so much. So next we have Dr. Sangeeta, who is scientist G in MNRE. In September 2023, on deputation basis, she joined, and she's the head of National Biogas Program, Small Hydro Programs. And she is presently also holding the post of Director General of National Institute of Solar Energy, Gurugram. She's been promoting bioenergy, small hydro projects in the country. Earlier, she has also worked as scientist and head of Energy and Environment Division at Department of Biotechnology, Ministry of Science and Technology, Government of India, and served for about 13 years. And she has promoted different types of innovations in bioenergy, environment, forest biotechnology, and comes with an amazing experience in biopolymer, carbon capture and utilization, bioremediation, etc. Her dedicated efforts have significantly contributed to achieve technology advancements towards climate change mitigation and biotech interventions to restore the ecological systems. Welcome, ma'am. Over to you. Kindly put it on full screen mode.
Audible?
Yes, ma'am, loud and clear.
Okay, and
your screen is visible as well, ma'am.
Okay,
right.
Thank you. So, basically, first of all, I would like to say that it is a really pleasure. All the panel members have already spoken about the various technologies for methane upgradation, biogas upgradation, and in the morning also earlier session from MNRE side to Mr. Jagdale, Joint Secretary, has also mentioned about the importance of hybrid renewables for Viksit Bharat. So basically, I would be talking about the National Biogas Program, which MNRE plays a very important role in bioenergy scheme. So let's see. Yeah. So, as you know that India has the target of net zero by 2070, and we have the target for capacity reached 500 gigawatt by 2030. That is based on non-fossil electric install capacity, and emission intensity of GDP to reduce by 45% by 2030 from the 2005 sector. So, as you know that renewable energy deployment is the central in achieving these goals. And hence the MNRE's various programs are being looked at that, so to reach that. So this is just overview of renewable energy. What is the status, the installed capacity in country, solar, wind and bioenergy. When we are talking about the biogas and bioenergy, is the total capacity is 10.715 is gigawatt, and total installed capacity is 10.73 as of now. So now we have to move on another 5 gigawatt. There is a potential for that. And ministry is working towards from various schemes, national bioenergy scheme with various components, which I will be talking on the details. So this scheme is launched in 2022. Basically, this is for 5-year scheme, 21-22 to financial year 25-26, with total budget outlay of 1,715 crores, and that is distributed in 2 phases. So there are 3 components: waste to energy program, the biomass program, and biogas program. Under waste to energy program, there is a generation of biogas and bio-CNG from urban, industrial, and agriculture waste, this is agriculture residues, etc., that has been taken as the feedstock for that. For biomass program, this is supported for manufacturing of briquettes, pellets, and promotion of biomass, that is non-biogas based cogeneration in the industries. And the third biogas program is basically to support setting up small and as well as medium-sized biogas plant, that is 1 meter cube to 25 meter cube biogas per day, as well as in medium-sized 25 meter cube to 2500 meter cube. That is for that the CFA, Central Finance Assistance, is given. And basically, just in order to make this ease of implementation, this has been made online submission, so anybody can log in for this, and there is a portal for that, and minimum documentation is required. And this has been the support is given either for the self-finance or through bank finance. And these projects, CBG projects, are supported under the Satat scheme of Ministry of Petroleum. And we would like to also mention that 20% higher CFA is given for special category states as well as Gaushalas. And registered and entitled entities also can implement gender biogas in consultation with state implementation agency. So the CFAs for small and medium-sized gas also will increase. And also we would like to say that in order to avoid the overlap with other ministries, because many other ministries also supporting waste to energy programs, especially MOHUA, Ministry of Housing and Urban Affairs. So MSW component is not here, only organic fraction is considered here to avoid the duplication. So this is a slide which gives the CFA Central Finance Assistance pattern, how this subsidy is given to various programs. So I will not go into detail, but just to focus on biogas and bio-CNG project, which are relevant to this program. So rupees 25 lakhs per 2500 cubic meter, 25,000 per cubic meter is given. And for bio-CNG generation, 4 crores is given for 4,800 kg per day, that is bio-CNG generation from for new plants, and 3 crore is given for 4,800 kg per day bio-CNG generation from existing biogas plant. And maximum assistance is given to up to 10 crores for each plant. Then power generation based on biogas also, there is a subsidy for 75 lakhs per megawatt for power generation from new biogas plant, whereas 50 crores for per megawatt for the existing biogas plant, and its maximum is given rupees 5 crores per each plant. Agriculture residues, the power generation from bio and agriculture residues, again 40 lakhs is given for megawatt, and maximum CFA of 5 crores. So this is just, and it is very important to mention that some states we have given special category state higher 20%. Higher CFA is given for northeastern states as well as Kashmir, Ladakh, Lakshadweep, and Andaman Nicobar Islands and Goshala shelters. As I mentioned earlier, the total budget is given 858 crores. Out of that is for only phase 1, that is up to 2025 and 26 year, that is for 5 years. Waste to energy program, the budget is given 600 crores, and for biomass program, the outlay is for 150 crores, and for biogas program, it is 100 crores. Now also we are also implementing this action, going for the phase 2 of these projects. So total current status for this is CFA is released is 30 number of projects given, and total 58 crores have been spent, and total sanctioned is already 244.9 crore already sanctioned. So these are under pipeline, as mean to say that these projects are under pipeline and will be implemented in next 2 years. If we talk about the overall, what is the contribution of this national bioenergy program? So, and earlier from cumulative capacity of 10.26 gigawatt has already been done for the biomass-based power plants and 0.58 gigawatt equivalent. So that is coming from 310 waste energy plants. So large biogas as well as bio-CNG and various industrial waste. So this capacity, this total capacity is 0.58 gigawatt equivalent. We have installed capacity coming from these. And from the biogas, small biogas, we have in the country so far 50.95 units have been installed across the country, and 10.7 that is equivalent to 10.7 megawatt. This includes both small as well as medium size biogas plants. So this is the total overview. This we can say that scale, and now we have to reach a goal, larger goal, and there also we have various schemes available, and we are also going to get more funds in coming years. And MRRE will be supporting and encouraging the waste to energy program, and biogas would be supporting. And we need to focus on how to improve the yields, how to improve the efficiency as well as purified biogas, so that this can be used for various applications, including power as well as biogas for transport fuel and cooking fuel also. And also there is a much potential for green steam and heat. So that is also we need to consider that. So with this, and this slide shows about the implementation mechanism. Once the project is submitted, and we have implementing agency, that is IREDA, India's Renewable Energy Development Authority. Through that, after documentation inspection, MNRE received this proposal, and then the in-principle sanction is given from the MNRE, and after the commissioning of project, then CFA, the Central Financial Assistance, is released through the IREDA. So with this, and we have the committee, appraisal committee, which also looks at the self-finance proposal or for bank finance. These are directly coming from the IREDA. So this is the overall scheme, and would be happy if there are any questions. There is communication. Also, we are trying to outreach, and I think IBA can play a very important role in communication. And all the stakeholders can make use of these schemes of central sector scheme, which is available at MNRE.
Thank you so much, ma'am.
I would just say this is the thank you so much, and I would be happy to take any questions. And this is the link if anyone would like to go through the website and take that. Thank you, IBA, for the opportunity. Thanks.
Thank you so much, ma'am. It was indeed a wonderful presentation with such concrete facts. Thank you so much for sharing those facts with us. And next we have Mr. William with us, who would like to share his views. So over to you, Mr. William.
Yeah, I'm here. Visible for my slide, PPT slide.
Yes, your slide is visible. Kindly put it on full screen mode. And also a humble request, Mr. William, we just have like 5 minutes to go.
Before the presentation, I would like to thank IBA and our sole distributor Daltech for giving me this opportunity. Aaron is a membrane manufacturer with over 20 years of history, initially starting with the nitrogen membrane, but we are expanding into the global market with our biogas upgrading membrane. Our business is built on three main pillars: hollow fiber production using the two material, and membrane module design and production, and gas separation system design and engineering consulting. Biogas upgrading membrane, operated by the utilizing compressed biogas. Generally, biogas contains CH4 and CO2. The small molecules like the CO2 diffuse through the wall of the hollow fiber in the membrane and exist from the permeate port. The larger molecules like the CH4 to be transported inside of the hollow fiber and exit of the end of the membrane we call the retentate. Aaron has the two kind of the biogas membrane.
Requesting everyone to kindly mute themselves except for the speaker.
Yeah, each membrane has a unique advantage. Gen 1 is designed for high permeability, offering an economical solution by operating under low pressure. Gen 2 features a high selectivity to guarantee the methane slip. Currently we have installed 5 biogas upgrading sites and 2 sites under construction in the South Korea. The first picture, Chungju City, is the important reference for us as it's specializing in producing hydrogen from the biomethane. And the last picture, like the Asan City, it is the biggest size of the biogas upgrading using the membrane in the South Korea. We are handling the 1,700 normal cubic meter per hour. And Aaron is always offer the customer technical support for the customer project through our simulation tool, as like the slide. The customer know the required number of the membrane for their project with provide our mass balance. I think it will help the customer to check or calculate the OPEX and CAPEX. If you have any inquiry about the biogas using the membrane, please contact our sole distributor Daltech or Aaron directly. Thank you, and thank you for your attention.
Thank you so much, Mr. William. And next we have Dr. Tushar, who would like to quickly, wrap up the liquefaction part. Over to you, Dr. Tushar. Dr. Tushar, kindly unmute yourself.
Thank you, Manisha. To continue with it, we have talked about the options of upgradations through membrane, and we have talked about liquefactions. The aspect of liquefaction is mainly addressing the challenging area of distribution of biogas. Now, the existing mode of distribution of biogas in India is compression. Compress the gas, put it in caskets, cylinder caskets, and transport it by truck. We are proposing that how you can compare a compression route vis-a-vis a liquefaction route on certain important aspects if we have to really opt for liquefaction routes. One of the areas first is very obviously the capex, the cost of acquisition, and what we see that yes, in liquefaction route the cost of acquisition is high, but the interesting part is when you're talking about cost of transportations, it is really low then compared to the compressed biogas mode. Then obviously the common physics or the common science says that in a liquid format you can carry an extremely higher number of molecules of biogas in one trip, so which are 3 to 10 times more biogas that can be transported in a liquid format. So that's the advantage of a liquefaction mode of transportation. Operation is obviously liquefied biogas, what is shared by Mr. Aryan. It's fully automatic system, so mainly operator intervention is very little, maintenance is very low, and impact on pollution, that's also one of the important part. The more number of trucks being used for transportation and distribution, you are adding pollutions to the environment. So since liquefied mode or liquid format is very little frequency, so it really saves or it really impacts on pollution. Recurring cost of such plants are very low, and scalability is possible. As you have seen, these are modular plants. So you can add modules to raise the capacity of the systems. Now we come to the interesting area.
Just a gentle reminder to wrap it up, sir.
Yeah. This is the almost the last but one slide. So this just wanted to say we have carried out a cost economics of a compressed biogas vis-a-vis liquefied biogas. And when you are talking about a particular distance, there are lots of assumptions in these calculations. We have taken care of everything. That means cost of acquisitions, the recurring cost, power cost, people's cost, everything put together. And if we find out that if you see for a 50-kilometer radius mapping, if the distribution is carrying bio transportations, the compressed mode is economically better. But when you are going for higher distances, which is 100 and 150, you can simply find out that liquefied biogas modes are becoming more and more economic and obviously helpful. So we just wanted to say this is a concept, this is a calculations which we have based on some presumptions we have worked out. We have definitely wanted to validate these kinds of numbers with interested peoples who can really help us out, and we can do it. Finally, what we mean to say that the technology which we have proposed in terms of purifications and in terms of liquefactions are already adopted worldwide. This has got a kind of, besides the tangible benefits, it has got intangible benefits which are gradually getting visible all over the world, and hopefully it should also be visible in India. As we have mentioned, economics will improve with extended usage and adoption worldwide. So this is something which we wanted to excite our audiences, our peoples, and we are open for all kinds of a discussion on these subjects, and we can have good dialogue for a better tomorrow. That's from my side. Thank you very much.
Thank you so much, Dr. Tushar. Thank you for those wonderful insights. And next we have Mr. Bharadwaj Kumamuru with us. And Mr. Bharadwaj is the Executive Director of World Biogas Association and has been a part of WBA since almost 10 years now, leading advocacy efforts globally. And he has authored articles, opinion pieces, reports on sustainability markets, policies, climate negotiations, and is presented about bioenergy developments at 70 plus events in 25 plus countries and led various trade delegations globally. So over to you, Mr. Bharadwaj. Very warm welcome to you.
Perfect. Thank you. I hope I'm audible and that the screen is visible. And
yes.
Okay, perfect.
Everything is great. Kindly go ahead.
Perfect. I'll try to keep my intervention brief, cognizant of the time that we have right now. So as mentioned, my name is Bharadwaj Kumamuru. I'm the Executive Director for the World Bioenergy Association. Thank you to the Indian Biogas Association for the opportunity given to us to intervene. In the next few minutes, I'll briefly share three things. One, the status of biomethane development around the world. Challenges in terms of feedstock, in terms of technology and policies and regulations. This is based on the vision document that we did a few months back, and also one slide on what's happening in Sweden, where we are located. Very quickly, the World Bioenergy Association, we are a member-based organization, an international advocacy group based in Stockholm, and we have members from both solid biomass, liquid biofuels, and biogas included in our membership. Firstly, in terms of biomethane situation, we see that there's both biogas and biomethane are experiencing significant interest, not just in European Union, but also around the world. A few weeks back, we were at the India Energy Week, and pretty much everyone wanted to set up a biogas at a CBG facility. It's the same interest in the US, in Brazil, in Southeast Asia, and so on. And the reasons are quite obvious, as we all know. Biogas, biomethane, these are mature technology, have been around for many decades. A critical component is its compatibility with existing infrastructure. And also that there are some sectors, especially heavy-duty trucks, that are hard to decarbonize or hard to electrify. And that's where biomethane comes into the picture. And if you look into the future, according to the International Energy Agency's net zero scenario, the sector, especially biomethane, has to increase by about 40-fold by 2050. So it's a very big challenge and a very big opportunity as well. And as Kees has already mentioned in his previous intervention, biomethane is a very critical pillar of the EU energy security. There's a target of about 35 BCM by 2030. I think the current production is about 3.5 BCM right now. If you look at the challenges, what we have seen in biomethane development, number one, and first and foremost, is feedstock, which is sort of the same with every other bioenergy technology. There are estimates show that only about 1% of feedstock is currently utilized right now. So there's a lot of scope for growth in the European Union, especially there's enough available to meet the 35 BCM target. But there are ways in which we can improve to access the available feedstock and also novel feedstock, whether it's in terms of national and regional assessments, efficient waste management frameworks, whether it's high cost of landfill, segregation, and so on, raising awareness of among industries, especially agro, dairy industry, breweries, and so on, about their available feedstock, and also accessing novel feedstock such as woody biomass and crops are some ways which we can make sure that we have more feedstock available. Technology is important. We've heard a lot of presentations from some companies on how innovations are happening. As you can see, on the TRL levels, anaerobic digestion upgrading is already well commercialized, but there are other technologies and pathways which are under commercialization. And there is some innovation still needed, whether it's in, as previously mentioned, avoiding methane leakages, optimizing plant performance such as modularity, standardization, and also commercialization of novel pathways such as gasification, which can unlock newer types of feedstock. Thirdly, on policies and regulations, at the European Union, there were high natural gas prices, especially driven by the war in Ukraine, has made biomethane very competitive with natural gas. But that's a very short-term measure, and there is a need for long-term policies to ensure that biomethane becomes a viable alternative. And these should include both supply side and demand side. And there's a mixed bag of solutions that can come up and that have helped the European Union to have more biomethane in their energy mix. On supply side, initially it has been feed-in tariffs, especially in Germany, and this is slowly moving towards auctions and public-private partnerships. And simultaneously on the demand side, there's high-level ambitious targets, whether it's a 35 BCM target. There's also targets on mandatory quotas for individual sectors such as transport, technology-neutral policies such as carbon pricing, and also policies based on carbon intensity, such as the California's low-carbon fuel standard, are some of the various policies which have helped the sector grow quite well in Europe and around the world. At the same time, the critical thing with biomethane is that it impacts so many variety of sectors, whether it's air quality, whether it's water quality, land use, emissions, and so on. So it's needed. The most important thing among the modifications of existing regulations, and that's something that I want to highlight, and that is something that most of our industry members have highlighted, is to speed up and streamline permitting processes. Right now, an average permitting, right from planning until the commissioning, it's about 3 to 5 years. And considering that we are, 5 years away from 2030, where most of the targets are, some of the plans have to be set up right now. So it's very, very important that the permitting processes has to speed up. And finally, the case of Sweden. The energy gases are a very small part of the Swedish energy mix. Biogas is improving, biomethane is improving. About 2/3 of biogas produced is upgraded and used in transport. There's about 280 biogas plants and 70 upgrading plants in the country. And the main policies that have helped are not just ambitious demand side policies such as renewable targets in overall, but also for transport, but higher carbon tax exemptions, as you can see, some production support and also support for investment. So it's a mixed bag of policies which have helped drive the uptake of biogas and biomethane in Sweden. That sort of is my final slide. I apologize if I've been very quick, but I've tried to make sure that I intervene in the short time that we have. To conclude, biomethane is a very critical component of the future energy transformation. Very important to have more feedstock available. Technology innovation is very important to commercialize novel pathways, improve performance as well. And finally, new policies and regulations should be incentivized for more biomethane production and use. So with that, I'll stop my intervention and I thank again the IBA for the opportunity given to the World Bioenergy Association to intervene. Thank you.
Thank you so much, Mr. Bhardwaj. This indeed was a wonderful presentation. I'm sure all our viewers loved it. So I just wanted to invite all of you to Bioenergy Pavilion 2024 on 3rd, 4th, and 5th of October 2024. This time it's going to be bigger and better, and we sincerely hope to meet all of you over there. So next, I think I would like to invite Dr. A.R. Shukla, our President, Indian Biogas Association, who has got more than 4 decades of rich experience in bioenergy sector and has even retired as advisor bioenergy with Ministry of New and Renewable Energy. So sir has been guiding us, and he has been our guiding angel who has been, motivating us to do better in the field of bioenergy. And all of us are fortunate to get blessings from him all the time. So over to you, sir.
Thanks, Mansa, and I welcome all the participants who joined today so that we can welcome them for our Bioenergy Pavilion 2024 from where you have just invited them. That will be nice that the bioenergy fraternity is going to be there, because we have put our annual event not only for biogas but also for the bioenergy. And as in presentations, it has been mentioned that globally there is a concern of developing this sector. Of course, a lot more things have to be done. As regards today's presentations, what has emerged that we have to go for a technology which is not only for other technologies, not only for one section or one sector or one aspect of the entire game. Being a difficult one, the best requirement and best solution for that could be that an integrated solutions not only for the gas stream, but also for the fertilizer stream, and before that for the feedstock stream. So the integrated technologies are required, and the span has to be larger. Not that unless you have this capacity, our technology solutions are not applicable. It should be from small ones to big ones, so that we are able to tackle this sector in a more fruitful manner as it is required. Now, the LNG and the cryogenic aspect which has been talked today, that was main focus, where Dr. Bhaumik, and he has been supported by his other collaborators, Mr. Keys and Sarjan, Mr. William. So all those persons have attempted to say that if they want to do, they will be requiring a biogas plant. And from that biogas plant, they are going to take gas, raw biogas, and that they are going to purify and have carbon dioxide liquefaction, separation and liquefaction, and the methane separation and liquefaction, and put up in a lower size, volume-wise storage systems, the cryogenic systems. Now, this is the gas aspect of it. What has to be taken care of is the fertilizer component of it. So there again, the integrated technology is required, which is yet to come, and whatever solutions have been offered, it has been offered only for one aspect of it. And the beginning of the sector, that is the feedstock itself, there again the integrated technology is required. Now, if the feedstock, the gas component, and the fertilizer component, if all these three things are taken together, and then the overall economics is worked out. So overall economics has not been very favorable. That is one of the reasons that the developers were not coming, because they find it difficult, one, and they find it lesser profitable. So for that, the policies, it has been mentioned that the policies have to be there from the Ministry of Petroleum and Natural Gas in India, and policy from MNRE in such a manner that all the three components are taken care of, and for that the efforts are being continuously made. So including the feedstock, the support has been declared by Ministry of Petroleum and Natural Gas. The Satat scheme for marketing of that, it is already available. and then MNRE giving the subsidy for different capacities of bioenergy systems and biogas and bio-CNG systems. Now, these are to be integrated together so that we are able to justify to the promoters that it is a very, very profitable business. And that is where in the beginning, the government policies are to be such where the risks are to be taken by the government to begin with. And for that, at least in India, the government is coming up with those policies, including the transportation of gas, putting in the gas grid system. It has been mentioned just today that the digestion, the innovation from the UNIDO, which my friend Kote has mentioned. So, and Dr. Sangeeta has given the MNRE thing. So, digestion, the innovation in all the aspects, including the fertilizer, are required. So, I hope that it will be possible for all of us together to see that the integrated solutions are provided for all the three components together, and whosoever is giving the solution has to say that now the profit, overall profit to the promoter is going to be there, not only one aspect of it. Only LNG, very good. It's very good if we talk only part of that, but what happens before that and what happens fertilizer component of it. So I hope that once we are working together, we'll be able to find better solutions and best solutions in due course, so that our targets are going to meet. And the manufacturing in India for any technology is to be an integral part. Otherwise, one demonstration okay, two demonstration okay, but the larger numbers will come only when the concurrent manufacturing plants are also met. So with that, from the Indian Biogas Association side, we thank the sponsors for this today's webinar, and all the my colleagues, Mr. Gaurav, Aparajita, Mansa, who is already there as a person available from the very beginning, Jyoti, and everyone, Abhijit, who have been supporting it, and Arjun is there, which have been flashing in between. So therefore, anything happening means a lot of efforts is there, and the big number of hands are there. So all the hands which has put this seminar and webinar successful from the IBA side and from the sponsoring agency, and all the speakers who have come and joined us. And so Vijay, who was in IOCL and who continues to be in IOCL, SOS-CBG. So therefore, all these persons and so Bharadwaj, some Ashish Maheshwari, who couldn't talk, but his technology, membrane technology, which has already been mentioned in the colleagues of Dr. Bhaumik, who has talked about it. So we hope that we'll be able to provide a good solutions. My thanks to all of you. And we will be waiting to be joined by you in our 2024 events. So thank you very much. Thank you, and thank you all the participants, to all of you, Dr. Jagdali and all.
Thank you so much, sir. Thank you so much for sharing your thoughts with us. Thank you so very much, everyone, for joining us today for this webinar, and special thanks to MBS for supporting the event. And on behalf of the Indian Biogas Association.
Thank you very much. Thank you very much. Goodbye. Goodbye.